Right, so guys, we're on the 20. Right, so I want us to go to the 2019 final paper, please. Right, come, yeah, Evo, there you are. Go. Right. Okay. Right, so I want you to start at question 1 of the 2019 paper. There.
Oh, that makes sense.
Okay. 2019, question 1. Okay. Right, start timing half an hour. And we must stick to that. Okay. Hang on, sorry, I'm stopping sharing. I'll start sharing again now, those people online. Okay. $2019, yeah. They write on from 2023. So you'll need paper. Please, can you just repeat what I said 17 times? That's the ones are right. For 2023, that became writing. Before 2023, that was. Just be grateful that it's not the other way around. Okay. So just a couple of things, guys. Okay. 100 marks, 1 hour. Okay. Using module 2. Hey, when you get the paper, there are going to be 3 papers there. You're not expected to answer all 3, right? You're just doing the stats. You are not doing finance and modeling and matrix and graph theory. You answer the stats paper.
They're all there. It's going to come. They're all there.
I don't think anymore. I think it's going to come. I don't think it's going to come. I think it's going to come just on stats. Okay, but the old days when the words right on all 3 pens. So in the practice papers, you're just doing the stats, right? Okay, I mean, you'll just get 100 marks in 1 hour. Okay, right. For stats, it's correct 4 decimal places unless told otherwise. You can always leave your answers as fractions as well. Okay, so if it's probability, I generally leave the answer as a fraction. But if you do change the decimals, it's 4 decimal places. Okay, yeah.
1 hour,
1 hour and. Okay. All right.
Okay.
So go try the first question. And you should have a 4-minute sheet with you, all of you. And whenever you're practicing, you need a 4-minute sheet with you.
I'm back. Okay, I can see that. Not going to be. Just asking. If I'm really the difference, I've done. Okay. We got to fix my snow bonding. I used to try to help the guys. I like slowly. I actually they make sense. So I to do. Yeah. Yes, but then I hope no. Yeah, no. No, it was sitting here. Yeah. Like I've gone with like once, so I like know them, but not. So I think if I fish out vegetable bowls and hearts or carrots.
Right, I'm giving you your timetable, which is just your one exam. Okay. So you start at 1 o'clock. Finish at 2 o'clock. When you do your exam, hey, listen. You need to know your exam number. Okay, you don't write your name when you write the exam. You write your exam number. Exam number. Exam number. You can write it down and bring it with you. Yeah, right. Olivia is not here. Christia is not here. Rosemary, I'm here. Rosemary, can you get your phone from me on Monday? Pizza? So take a photo of your exam number now, guys.
What would be the?
Oh, I'm gonna go there, I'm gonna. What number is gonna follow on 24 or something.
But
You want to see her face? Yeah, you put mine on my. No, they. So bad. That's not unfair.
How would you write that picture?
no, but yeah,
So
Let
that
me-
means, yeah, you have, times by
make
two,
her.
right?
Is not.
You're doing the actual probability.
Mate, yeah.
But try it.
No, 2 quarters of a leg. 2 quarters of a leg. Then 50.
Emma, Juliet.
The last. Where's
The people, yeah, all, question. That day, no. No, the morning of the exam, you don't have school, guys. You don't think 1 o'clock, what percent says there? Madison,
Yeah. Originally said.
isn't it?
Are we allowed to bring this in?
Okay, I'll put it on Teams now, Rosie.
Right,
For
into.
Kanya,
So we're allowed to bring this in?
I think so, yes.
Right.
Danny,
No, yeah.
Amy Stubbs, everyone got this?
Third, okay, B.
Okay, I'll put the 2019 back on Teams now.
The probability.
Sorry guys, I'll put that up on Teams, I'm sure I put it up.
Will we yell at one?
No.
The first one.
Right.
Then two.
Yeah, so it would be an hour.
And if we get the
Green bean. Yes.
choose one.
No, you're quite right. Sorry guys.
Yeah. Yeah.
But then how do we work out it has to be? It has to be.
Of the third one being green bean.
Okay, let's go with the thing, put being in green, it's called green. Green.
Okay guys, they're up now.
I'll try. There's gonna be a green. And then green, yeah, green,
Guys, what if you're wrong?
That makes sense. But then how?
I did that, but I think it's not. What did you do? It's the only thing that matters is the last. Right, so one.
Okay, so I'm gonna say good right, you don't have to listen to me, good wrong you can. So A should have got 28 over 55 or 0.5091. And B, you should have got, I know, so I'll give you the answer for those who have finished, doesn't mean if I give you the answer, doesn't mean you get. Okay. B, A was 28 over 55 or 0.5091. And B is 7 over 11.
Oh, I'm so close.
Right, I'm gonna go over the notes.
You get that for the first one, yeah. I would actually put it in the middle. Oh, I get it. I should.
You can't get on your notes.
Can you just go over how?
Yeah.
The other one?
I'm gonna go over the notes. All right.
I feel like it would be that without. Wait.
Yeah.
I don't know.
So how was that presentation out of 6 marks?
Yeah.
That's so off-putting.
Well, it'd be great because it's got 100 marks. If they were all long questions for lots of marks, so just don't worry about the mark allocation. Okay. Then take the 3 batches and eat them. So the order doesn't matter, so it's a combination, right? Okay. So the probability of the event is always equal to the number of the ways the event can take. The event is what we want to happen, the sample space is what we're doing overall. Okay. What are we doing overall? We're choosing what? Okay. We're choosing 3 vegetables, right? From how many? I went to the sample space first. Okay. From 11 vegetables, we are choosing 3. So that's the sample space. Okay. Okay. What do we want to happen? I want to get 2 green beans and I want to get 1 carrot. Oh, where is that? I thought carrot earlier, but the carrot question. Coincidence?
I think that.
No. Okay, right. So if I want 2 green beans, I want 2 green beans from how many? 7. And so times, I want 1 carrot from how many? Okay, and you log that into your calculator. And if you left it at 28 over 55, I wouldn't bother to change it into a decimal, but if you want to, you get 0.5091. Everyone okay with that one? Am I good?
Yes.
Anyone like my hands?
So.
Am I bleeding? No, this is coffee. Why? Why I did not have the shirt on this one.
So it's another piece.
Okay, that takes the top, otherwise it would be a traumatic lesson for all of you. Right. Okay. Can I rub it out? Okay. Right. So let's try B. Okay. So in B, okay, it's a probability that the third vegetable eaten is a green bean. Okay. So there's lots of options for the third vegetable to be a green bean. Okay. So
You can go carrot, carrot, bean, 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 carrot, bean, bean, or bean, carrot, bean. Is that how you would do it? So
okay.
is that
So
how
then,
you-
listen. Okay. So we could either get yes. Okay. So tell me what you could go. The probability of the event could be okay. What has to happen? The last one has to be a green bean, right? So it could be carrot,
Bean,
carrot,
bean.
bean, or
Bean.
are there 3 beans?
Yeah.
Okay, 7 beans. Or carrot, bean, bean,
Or bean, carrot, bean. No.
or bean, carrot, bean.
Or bean, bean, bean.
Bean, bean, bean.
Have I left that in? Or bean, bean, bean.
No, we just do it like that, sir.
Carrot, carrot, bean,
Don't them not.
or carrot, bean, bean, or bean, carrot, bean,
So
or bean,
only
bean,
give
bean.
me 3 beans.
Okay, so are we happy that those are the options? To get the last one is a bean. Okay, so
The third one. But so, so you're not picking all the vegetables.
you're taking
still
3
picking-
vegetables.
You're still picking 3.
Yes, you're picking 3
But you didn't
vegetables.
really make that specific, so. I didn't.
The clue is the word third.
I know, but it could be the third out of all of it. You could pick all of them.
But in the here, it says, at the top it says randomly takes out 3 vegetables. And that applies to A and B. If there's an A and B, whatever's given here applies to A and B. Okay. Okay. So, in all cases, the sample space stays the same, right?
Yes.
What's the sample space? So the probability of the event is number of the ways the event can take place over the number in the sample space. The sample space, so I'm going to just make one denominator because it's the same for all 3, right? And what am I doing overall? I'm choosing from 7 things, I'm choosing, no, from 11 things, eh? How many vegetables are there? 11, right? From 11, I'm choosing 3. That's the sample space always. Okay. So then, for this one over here, carrot, carrot, bean. Okay. But now an order matters, right? Okay. So for the first one to be a carrot, okay, what's the probability of the? I'm choosing 1 carrot. Oh, mom, thank you. I'm choosing 1 carrot from. Thank you, eh? From 4. Then I'm choosing what? 1 carrot from how many?
3.
So
Okay.
can't you just say from 4 to
Yeah.
I'm not sure. I don't think so. Because we're looking at order.
Then would
Thanks, eh?
Wouldn't
No, but what happening first of all? It's how many ways I can choose 1 from 4, right? And 1 from 3. And then what am I choosing? And then I've got a bean, right? 1 from how many beans were there? 7. makes me nervous. Why is it making me nervous? 1 from 4, 1 from 3, 1 from 7. No, hang on.
So what was your one if circle?
No, wait. Let's not do I suppose not comparing. Guys, combinations is not going to be the way to do this question. Okay. Let's just look at, okay, sorry. Because it's a bit messy. Okay. So let's think about this actually logically. Okay. So the probability of getting a carrot in the beginning is what? So of the first one being a carrot. I'm looking at this thing over here. Okay, not everything's permutations and combinations. Okay, so the probability that the last one is a carrot. Last one is a bean, eh? Okay, so if I look at this, but just it's an or situation, right? So what's the probability of getting a carrot in the beginning? Okay, how many? There were 4 carrots and 7 beans, 11 vegetables, right? So you randomly put your hand in. What's the probability of getting a carrot? 4 over 11. So it's going to be 4 over 11, right? There's no replacement. Okay? Then what's the probability of getting another carrot? Now you've got how many vegetables there? You've got 10, 3 of which are carrots, right? Because you've taken out. Okay. So 3 over 10. Right? Then what's the probability of getting a bean? 7 over 9. So that is the probability of getting that. It's like a tree diagram.
Could you like 100% wrong the combination?
You maybe could. Then you always some way you could, but I don't know how you would, quite honestly. Okay. So target the next 4. So or is what's in probability. So you've almost got a tree diagram where it's going carrot, carrot, whatever. So now try to do this one. Carrot, bean, bean. Final answer should be is 7 over 11. Right? So then, Alison, if you're nice in the new scenario, right? Probability of getting a carrot. Right? Probability of getting a bean. 7 out of 10. Probability of getting another bean.
6.
Yes.
No, I'm certain.
Inspiration does all. Right. Then look at that one over there. So Leia, what's the probability of getting a bean in the beginning? And then a carrot?
What?
And then not a bean? All that. Oh, hello.
Hi, so how are you?
All right, Nick? Right, and then you've got bean, bean, bean. 29%. Guys, just, by the way, make a note on the 22 paper. 22 that I gave you separately. Okay, I'm not going over this one. There are videos for this. I'll send you the links. Okay, videos for the solutions for 2022 paper. Okay.
So if you were talking about, maybe I did it wrong, but.
Okay, just have a look. And then the next one, okay, so it's a 3 beans. Okay, what's going to be the probability?
7 over 11 times 6 over 10 times 5 over.
Okay, so never says 4 over 11 times 3 over 10 times 7 over 9 plus 4 over 11. Yep. So. Yeah. There must be a calculator. Okay, so you end up with 7 over 11. Yeah.
What I did for the combinations.
I did really. Did you get 7 over 11? No, then I'm going to go. Okay, guys, it's not really a combination situation. Why isn't it a combination? Because there's an order going on here and there's no replacement. You with me? Okay, you can't think of this in terms of a combination. Because there's order. Combination does what? It just says how many ways are there. In the first question, we could use combinations 1. Because there's any order, right? So whether you had the green one or the bean was first or last or second, didn't matter. All that had to happen is we actually had 2 green beans and 1 carrot. There was no order. As soon as there's order, it could be a permutation, but this is not really a permutation scenario. You could talk about permutations here, okay, but even that is long-winded. Permutations are really just normal probability questions. Okay. So a combination is not going to work in this scenario at all, I don't think. I really don't think you can do a combination at all in this question. Because the whole point of combination is order does not matter. And here they specified that order matters. The being has to be last. Okay, it's not just one being. Okay, the being has to be last. Are we having that question now? Okay, so don't always think. A lot of you get to these numerical ones that you think it has to be a combination of permutations. Sometimes it can be a branch of a tree diagram. It can just be normal probability. Probability is the number of ways events can take place over the number in the sample space. Right. How about time?
So,
Yeah.
the answer is 711, right?
7 over 11.
7 over 11. So then, but isn't that literally just the green beans over the total amount of vegetables?
That's just coincidence.
You think so? It's
Yeah.
7 marks, it won't do. Well, you
Yeah,
can't
that's
do
just
that
that's
with
just
7 marks.
that's just coincidence.
Yeah,
Just coincidence.
that's just science.
Promise. I know, but that would practice you'll start to realize, okay, that a lot of them aren't permutations and combinations. I know they're hard. Okay, normally the big news is these permutation combinations will not be the last question now. Okay. Guys, money's not going to help us. Right, let's go to question 2. Okay, so let's try to identify the question. Pick your neighbor. Go. 1.2.
Sorry, I read to be right.
Okay, so he.
Religious being is less than or equal to 3.
But now I don't know how to.
10% of the and so that's what it is. And it's 2, 5.
There's nothing fancy about 1.28, guys.
Yeah. 5, 2, 6. And then it's 0 to 3 and 0.7 to 2, right?
Is it binomial? Or is it because it's discrete data, right? Okay, we're not looking at continuous data, do you agree?
Yes.
Okay, so if B, you've got to ask yourself, is it a binomial question or is it a combination question? What happens in a binomial? I always look for binomial first.
I think it's
Binomial is 2 outcomes,
But
right?
they are 3.
Okay, is the probabilities, are the probabilities fixed? Yes, they are. Okay, because we know the probabilities for the whole population. Those probabilities aren't changing, right? Okay, so B is a binomial question because the probabilities aren't changing. Okay, this is from 20 for a whole population, right? B, you should have got 0.9692. Yeah, and then, well, yeah, I got So guys, for A, what are you going to do? There's 20 people. What percentage of the population doesn't wear a watch?
10%.
So it's going to be 10% of 20, right? That's what we'd expect. Which is 10% times 20, which is equal to 2. That's all that is.
Zeros. We'll just do 1 minus.
But taking out 5 students from a massive school is not going to really affect. Why do I know that this is not combinations? Why do I know that this is not combinations? Okay. This 20 isn't got to do with this question, by the way.
Yeah, let's say.
Okay, they're separate. The question was just, okay, this is what I look for. Just look for, listen for a second. Okay, because the real hard part is knowing, is it binomial, is it hypergeometric, or in other words, combination. And the thing I look for is, do I have the size of the parent population? What I mean by the parent population in this case, it's the number of kids in the school. Do I know the size of number of kids in the school? No. So I cannot use combinations. Okay, because combinations, you need to know the total size. You're choosing 2 from 1,000,000 or whatever it is, right? So the only option is binomial. Because we're assuming it's a big school, and by taking 5 out, we're not really changing the probabilities of anything. Okay. So this is a binomial, your probabilities are staying the same. So I always look for that. I often answer questions about factory makes a lot of things. That's binomial, because the probability is not changing. Combination that say the probability makes 30 and you pick 10. Yes, well then by taking out 10, you're changing, by withdrawing things, you're changing probabilities, and then it's a combination. Okay. So probabilities are fixed here. Okay. And there are only 2 outcomes. The 2 outcomes I'm interested in are what? Where's the watch on the right list? Doesn't wear a watch on the right list. That's what we're interested in this question. Yes, there's 3 in the question, but this particular part of the question is only interested whether you wear a watch on your right wrist, right? Okay. So in this, we're going to use this formula. Probability x is equal to x is equal to ncx e to the x 1 minus p to the n minus x. You have to know on your formula sheet what all the formulas are for. In this case, what is n? Good. If we define x as the number of students who wear watch on their right wrist, what is p?
X.
What's p, guys? What's p?
0.
On their right wrists was 0,3. Okay. And what are we? Okay, so what does the question say? The question says, hey, find the probability that most 3. Okay. So at most 3 could be 0, 1, 2, or 3, right?
Yeah.
Okay, but how many things were there? So you could do it like that. So you could say probability at most 3 is the probability that x is less than equal to 3. So you could work out probability x is 0, plus x is 1, plus x is 2, plus x is 3. That would work. It'd be a bit quicker though. Okay, if you went 1 minus the probability that x is greater than 3. Okay? Do you agree with that? Either x is less, they're complementary spaces. Either they're less than equal to 3 or they're bigger than 3. So it's going to be 1 minus the probability x is equal to 4 plus the probability x is equal to. Does that make sense? Okay, so now you're going to use the binomial formula for 4 and 5. And you should have got an answer of 0,9692. Hang on. Why did I just do 4? How many people?
There's 5.
There are 5.
Yeah. So you have 2 minus 4 and 5.
Yeah.
But yeah.
If you minus 1, 5, you get 96.
So make a difference.
Oh, sorry, what I should do for the variant, that's the mitigation. Yeah, that's the mitigation. Yeah, I'm just making sure you know. Oops. We'll check how many responses for those that we get in. What was it that you can answer? 692.
By the way, in memos, I just look here for a second. Sometimes in memos, you'll see that this is just written as 0,3 to the 5. Okay, because 5 to 5 is 1. And into the 0 is 1. So sometimes you'll just see that bit in the memo. Okay. Right, and you should have got an answer of 0,9692.
Yes, yeah.
Well, you don't have to.
Okay with B. Next question is the normal approximation to the binomial question. So how does the normal approximation to the binomial work? What are the things you have to remember? Okay, for normal approximation. Okay. So normal approximation to the binomial. When do I use it first of all? I use it when it's just going to be a pain in the ass. Okay, so if you had like 20 things and you wanted to work out the probability x is greater than 8, to do the binomial, you have to go 8, 9, 10, 11, 12, 13, it's going to take forever, right? Okay, so what are the things you have to remember for normal approximation to the binomial? First of all, when the data has to be balanced. To do that, there are two tests. You can use it if n times p is greater than 5. And what else?
N1 minus.
And if n1 minus p is greater than 5. So that's when I can use a normal approximation to the binomial. Sometimes they ask you after the question, sometimes they ask you before. Okay, if it's appropriate to use it. Okay,
Do we have to check now or not?
okay. What do the questions say?
They said using.
They say using. So then you can use it, right? In my opinion. Okay, so afterwards they ask a question about justify.
No.
Unusual there. Okay. Then, okay, if you look at your formula sheet, go to your formula sheet. Okay. So you're going to use a normal approximation to the binomial. Okay. But to do that, you need to know mu and sigma. Okay. Or in the normal, if you move this onto a normal distribution, what you do is take discrete data and make it continuous. Okay. So if you look at your formula, okay, it gives you a formula over here, E of x. What is that? N E of x is equal to NP. That's for a binomial. So take a note there. So if they give you a binomial distribution, quiet please for a second. If they give you a binomial question, this E of x is equal to NP is for discrete data for a binomial. What would the question be? To be what is the expected value? So in the previous question, I could have asked you here for this question, what's the expected value of if you had 20 students? A was actually an expected value question. You worked out the expected value of 20 students by going NP, right? Okay. So E of x is equal to NP is your expected value. In continuous data, so when you go from expected value is a mean, a mean value can also be asked as that. So for continuous, you can use that to help you. So to figure out mu, okay, so on your formula sheet, it says Ex is equal to NP. That's for binomial. But if you move it, the binomial into continuous, which is what we do when we make a normal distribution, we're going to use mu is equal to NP. And we're going to have to work that out. It also says on your formula sheet, variance of x is equal to NP1 minus p. Okay? What's the relationship between variance and standard deviation? Variance is the square, standard deviation is the square root of your variance, right? So your standard deviation, if you make the data continuous, okay, this is sigma squared. Sigma squared is NP1 minus p. So sigma is going to be the square root of NP1 minus p. So use your formula sheet to help you remember those two things. Because to work with a normal distribution, you always need mu and you need sigma. Okay, and then you're going to get the z score for that. The final thing is this, guys. Just wait 1 second. In a normal approximation to a binomial, you have to do a correction. This is the only time we worry about greater than or equal to in a normal distribution question. Normally it doesn't matter because at a specific value. So if I gave you a data set, okay, and I wanted to know the probability that x was greater than or equal to 15. Okay, what you've got to do, if that was the question for binomial, you've got to do a correction for continuous. Okay, so what do I say? I've got to include, I think of individual value as being a bar. So if I think of 15s, let's say 15 was over here. I think of 15 as being a bar on the curve, and I want to include all of the 15 bar if it's greater than or equal to 15. So here my correction would be 14. I think of the end of the bars as being comma 5, right?
Yeah.
So in a normal, if that was for binomial, when you move it into a normal situation, you'd have to look at the probability x is greater than or equal to 14,5, because then you'd include the whole of the 15 bar. If the question was what's the probability that x is greater than 15, in binomial language, when I move it into normal, what's x going to have to be? Don't want any of the 15 bar now. So you go from 15, 5. So you have to work out the probability x is greater than 15, 5. So 3 things you have to remember about a normal approximation to the binomial. You can use it in those situations. And you have to figure out mu, you have to figure out sigma. Use your formula sheet to help you, and then you have to do your correction on your normal diagram. Okay. Time. We'll break off this question. Break after this question. Everyone understand? Can I move back? Okay.
Wait a second, you could, for 1 second, go back to that phase.
Yeah.
There be no sometimes line of
Oh, yeah, you're right.
and then use another.
Oh, look, everything else goes, so it's not even big focus
Yeah.
again. Yeah, that's fine.
Okay, so what's the say? Okay, do you understand that using binomial would be ridiculous?
Yeah.
If you have to go 125, 126, 127 up to terms, right?
Yes.
Okay. So, in this particular survey, if I'm going to use a normal approximation to the binomial, if they didn't ask me, I think I'd still show it personally. So what's n equal to? 200. What's p? Left wrist is what? 60%. So p is equal to 0.6. X is equal to probability x is equal to
120.
number on
It's always.
left wrist, eh?
Yeah. It's more so great.
That wouldn't be nice if we didn't know. Okay. So first of all, if they ask you for justification, yeah? Yes. If you're going to use justification, okay, your justification for using this would be what is NP? NP is equal to 200 times 0.6, which is what? 120, which is bigger than 5. The other one is N1 minus P, which is 200 times 0.4. What's that equal to?
4/3. Oh,
No.
oh, wait, I already
That's
squared it.
16, no?
Just work it out. 100 times 0.4.
4/3, so.
No, because that
It's
equals, when you get.
0.4 times 200 is, oh, no,
80.
yeah, it's 80.
Yeah, that's cool.
Oh, yeah, but you were talking about.
Okay, so that is a justification. So that, if they ask you for a justification, that'll be it. They haven't specified here, so I don't think they're penalized in this particular case. But normally the first question is it appropriate to use this?
Yeah.
Okay, and that's how you justify it. Therefore, normal approximation is fine. Okay, I don't think we need it for that particular question though. I'm just curious to see if they put it on the memo. They actually did. Remember they did mention it.
Is there a mark for that?
Yeah, they have a month for that.
Oh.
Okay,
So they don't tell us to do it, but we are expected to do it.
okay. But they didn't this year.
But it's it using.
I know. I'm just saying.
So should we just wait one
I would always just do it. Okay, right.
They gave a mark saying that's greater than 5. Well, no.
Okay. So now I've got to find mu. So mu is equal to NP. So for normal, so mu is going to be equal to 120. If you get sigma as a third, leave it as a third.
Yeah. The mean is. It gets a great standard deviation. So what was that? How did you work out Yeah.
Very fun.
Or, I mean.
Or in three.
Yeah.
Root 48.
Yeah. How's it usually? No, you look at the bar.
Root 48 is the same thing as 4.
Minus EX squared.
Okay.
But I didn't.
But either format's fine.
Yeah.
Right. Are we good with sigma?
Yeah.
Right. So now I start drawing a picture. And in the normal, I want a diagram. Okay, so
Looking for the region beyond one.
So what are we looking for? Okay, the question said more than 125. So if the binomial you'd work out probability is x is greater than 125, right? That's for binomial. But we have to do our correction. Okay, so where is mu? Mu is at 120. So here are my x scores. I'm going to break down. Okay, oh, what a nice day. Okay, so mu is equal to 120. But we're looking for, so think of 125 as a bar. Okay, so 125 is a bar, and we want greater than 125. But if I don't want any of the 125 bar on normal, what's my correction going to be? X is greater than equal to, doesn't matter, 125, comma 5, because then I don't include any of the 125 bar. Fish? If it had been X is greater than or equal to 125, it would have been
124.
That's it. Okay. So on my normal distribution, I'm using 125, comma 5. So I'm looking for this area over here.
So then when he's working out Z, do we have to say 125?
You have to use 1.25 to the 5. That's allocated about 2 marks to this question. If you didn't do the correction, you'd lose 2 marks. So now I need to find my corresponding Z score. Is my Z score going to be positive or negative? Positive, to the right of the mean, right? With me. I'm saying, the question said, in a binomial, we wanted more than 125.
No, I understand that.
Okay.
Now I'm just figuring out what.
Okay, so now I'm going to find the Z score that goes with 125, comma 5. To do that, I'm going to just use Z is equal to X minus mu over sigma.
Yeah, no. But then how are you gonna get that?
Oh. Would you write that actually? Would you write it like that, the PX greater than?
Okay, so you're going to work out Z, right?
Yeah.
So Z is going to be equal to, what's X? 125, comma? Mu is,
120.
sigma is.
4. Oh, that is.
Okay, so go get your Z score to 2 decimal places. 0.79. So this Z score over here is 0.79. Okay, so when I use my table, the table is going to give me the blue area. So we want to work out the probability that X is greater than 125, means the probability that Z is greater than 0.79. Okay. So if I look at 0.79 on my table, what's this area over here going to be? So H of 0.79 is 0.2852.
Yeah.
Everyone check that you know and read that all. Okay. So the probability that Z is going to be greater than 0.79 is going to be, what am I going to do to this? To get the red area, what am I going to say? 0.5 minus that. So it's going to be equal to 0.5 minus 0.2852.
If you have to write all this working out down, can you just go straight from reading?
The examiner kind of likes that setup. Okay. It can be a bit of tight sometimes.
So, this is examiner. Hi.
Dominic Clark from St. John's. Right.
I'm going to write off
Okay. Right. So if you go work that out, what do you get?
0.2148. Woo! Break time.
Next time. Right. 11:13. Okay. We're on. Is that right?
Yes.
So,
Yeah.
if I worked out Z, then worked out H of Z, then went 0.5 minus
Yeah.
that.
I really doubt you. All right. 11:15, 11:14, 11:25. So 11:25. People at home. Overall.
Okay, I'll catch up. Oh, it's so good. Oh, it's nice. That's what? It's just very nice. I see what's in there.
What?
Can I see what that is one?
Okay, let's take those.
I don't know what it's going to be.
And combination of food.
Oh, we open the door. Yeah. Right. Example. Yeah. 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 Ready? Being so good.
I've never done this here, even though I'm in the one.
Well, say one. Yeah.
It's fun.
I don't think so. Could find ways to be honest.
Yeah. But then, we get 125, you'll want to pop them, that's fine.
So that's become an
Yeah, but it has to be. That's a single, probability.
It's not perfect.
But that's not the distribution. The other should be.
I'm like, it should be so then to this X. Just. Thing up, right, this thing.
You had a big one.
No.
Get to the next one. Be something more. No. That's just hard. It's not so simple. I kept going home. We're so close.
I don't even know what's happening.
Like so. I know, but not very.
Oh, there's like, it's not mistake. I have to finish the first one.
Today I think you're
I'm so glad it was
Voted that's first.
I'll ask Nick.
And I can't understand a bit, how do I say, so I'm not going to feel me.
Oh, no, that's not very, I'm not very bad.
You add one.
By that accent.
But then it's zero.
Wait.
And you can't provide anything like that.
I'm telling you, it's not fair.
So good. You gave me another thought.
I'm going to watch any of this.
Everyone. How do you integrate?
But I really don't want to.
So you feel like you.
I really don't believe this is the.
I think Flo is gonna but you know, what's it this week?
What?
Also, they change.
Oh, yeah.
Oh, shit. I just think it's very something much.
I might have integrated one. Everything.
Move.
I don't know.
Did you sorry. Hey, we can't see the member.
Like that's just.
I've been listening.
Yeah.
Come after this.
I think you might take probably.
Yeah, he's been on my.
We just said that you, with one of the X's. But I don't know.
I need some too much.
That was because you were there, AC.
I know. This is a different language. Anderson has its own.
And she calls it that you. That's just a lie.
So as far as those.
That's so much sense.
I'm just waiting around things don't have anything.
I feel that makes zero sense. I don't know what. Sure.
How can you be doing but then getting someone and then so you don't.
Yeah, but if you. We're seeing that's going for the.
No, and then I think, oh, no, and then I think,
Oh, no, yeah, but we just break this. I'm gonna go. She's so. She, maybe she wants one. I just go. Oh, right, just. But sometimes. I'm guessing the stuff in. I don't know what's going on. I said, oh, people want to do it, but it's unbelievable.
Okay, let's keep going, guys. Okay,
It's not fair, they put lens everywhere.
okay, hang on. Right, so guys. Okay, so guys, put your formula sheet, right, go to your formula sheet. Okay. This bottom right formula, E of X is equal to, sorry, this formula here, is equal to sigma X, probability X is equal to X, right? And that formula over there is for discrete data, that's the expected value or the mean of discrete data. Okay, so for discrete data, sometimes they ask this question in questions, what's the probability distribution called for discrete data? What's the probability distribution for the time half an hour, please? Probability PMM, right. So often this comes in probability mass function question. If they say to you, what's the expected value or what's the mean? Okay, then you're going to use this sigma X times probability X is equal to X, where you're just finding the X score by the probability and you're adding them all up, right? Okay. What is this formula here for? You've also got this, E of X is equal to NP. That's when they ask you for the expected value for it, so just make a note in your formula sheet. That's usually for binomial. Okay, but we can use that also for mu when we're finding the normal approximation to the binomial, right? Okay, and likewise, this variance of X is equal to NP 1 minus P. Both of these formulas over here have to do with binomial distributions, but remember we can also use them to help us, okay, with the normal approximation to the binomial. If I've got a probability mass function, okay, then the expected value of the mean is equal to that. And there's another formula bottom left, which says that the variance, and how do I find the standard deviation from variance? What's the relationship between standard deviation and variance? You square root the variance, you get the standard deviation, right? So the variance is equal to E of X squared, which means the expected value of X squared, okay, I'll explain that now, minus E of X, E of X all squared. So that's what you're going to use to find the standard deviation. Okay, I'll do that now. Okay, so. No, I think you have to show that, I would think.
So could we not just say?
Where's my memo?
One minus P. No, yes, sorry. So
Yeah.
why don't you just do the square root of NP 1 minus P?
Because that's for binomial data. Okay. Okay. All right. So let's have a look at this question. So first thing, let's go try find the mean using this formula. Right, off you go. Go find the mean for A. Okay. It's so fun, Danny. Thinking Maddie. I know, man.
What the sigma?
Let's take notes.
Could move, sir, it's not or genuinely concerned. You need to do that to any decide tea lessons or leave a glass of nice beer.
All of the, one.
Right, so go with that.
But like diagnosed with hearing, aid, I could go into an exam and give you like a microphone that you could speak into. Yeah.
That's how it's like, guys.
Like, genuinely.
So if I do a probability table, it's going to be if x is equal to number of x, you want to redraw a table. So x is equal to the number of x. Okay. Then if you have x and probability x is equal to x, it's going to be 1, 2, 3, 4. What's the probability going to be? Well, there are 90 seagulls, right?
Yeah.
15 had one egg. So what's the probability of one egg? 15 over 90, which simplifies to
1/6.
Okay, so your probability table, I finish that probability table first. Because to work out E of x, I need the probability. Because there were 15, this is 15 over 90. Because 15 females,
Do this, sir.
yes, you would. 15 females have one egg out of 90. So the probability, well, it's easier. I prefer working with the table. No, you don't have to use the table. Okay, so what's going to be the next one?
45 over 9 to the
Which is?
half.
Yeah.
And then
2 over 9.
20 over 90, which is 2 over 9.
And then 10 over 90, which is 1 over 9.
Those probabilities should add up to 1. It's going to be 3 over 9 plus 1 over 6. 18.
41 over 18. Okay.
Probability.
Well, no, they won't do
No, the expected value is
Oh,
probability.
the expected
Okay.
value.
All right. So if you add up those, they'll add up to 1. Promise. Okay. So now, okay, the question says find the mean. Well, the mean is the expected value, which means go add up your x times p of x. So what's it going to be? 1 times.
1
Danny,
times.
stay with me. 1 times 1 over 6 plus what? Carry on, Danny.
2 times.
Oh,
2 times 1, yeah.
Did you guys carry on?
2 plus 2. Yeah.
It's nice when I identify you as the same person, because then either of you can answer and ask the question.
What is it?
And you should get 2,28.
Yeah. So.
Yeah.
Trying to call this. It sounds stupid.
What does that mean? On average, a seagull has
2.28
2,28 eggs. Yeah.
Can we not just add up all the eggs and divide them by
Probably will give you the same
90?
answer actually.
Yeah, it gives us the
Yeah.
same answer.
And you-
Really?
Yeah, so you can go 15
Yeah.
plus 90
Regular call.
plus 60
Yes.
plus 40 divided by.
By 90, yeah. No, you say one.
How many eggs were there? There were 15 plus 2 times 45 plus 3 times 20 plus 4 times.
Times 1 plus 45 times 2 plus 20 times 3 plus 10 times 4 over 90. Yeah, because there's nine.
Yeah, you get the same answer.
Exactly.
Okay, but normally they can be that table as a probability table, so you have to use this.
Yes, yes,
Okay.
yes. But I'm saying.
Yeah, you could have perfectly correct. Okay. Now, to find the variance, okay, we're going to use this formula. Okay, now just have a look how we use this formula, please. Okay, so the variance of x, okay, is going to be equal to E of x, just listen, please pay attention. This bit over here, E of x squared. Okay, well, to find E of x, I went 1 times 1 over 6, right? So here you're gonna go 1 times 1/6 squared. With me? So to work out this part of it, to work out this part over here,
Yeah.
okay, I'm gonna go, so this part is gonna be 1 times 1/6 squared, which is 1 times 1/36. You with me? Okay, so this part is the E of, this is what they mean by E of x squared. So it's gonna be 1 times 1/36 plus what, do you think? We're using this formula here, right? Which is in the bottom left side of your page. Times
But 2 times the half square.
2 times the half squared. Which is 2 times a quarter, right? Put that in. 1 times 1/8. Later. Hang on. No, I've done it the wrong way around. Pause. I was being a knobhead. I was being a knobhead. Sorry. Okay, we just relax. So it's E of x squared. So you've got to square the x, not the probability.
Yeah.
So minus, okay, E of x all squared.
Yes.
Okay, apologies. So you've got to square the x. So it's going to be 1. So if I have a table for x squared, what are my x squareds going to be? 1,
1,
4,
9,
9,
16.
16. Apologies.
Oh, but then.
Okay, so now you're going to go x squared times your probability.
So 1
So that 1 times 1/6 plus 4 times a half plus 9 times 2/9 plus 16 times 1/9.
It should be 100.
You with me? Okay, so it's E of x squared. Square the x's. Not the probability, sorry.
Oh, so you're going 1 times
So
1.
it's going to be, so about, when they talk about E of x squared, they're talking about 1 times 1/6. You with me?
Yeah.
Plus what?
Plus
4 times 1/2. Plus
9 times 2/9. Plus 16 times 1/9. What?
16 times 1/9.
1/9, yeah. Sorry.
That, guys, is this bit over here. That's E of x squared. Have we worked out E of x? Well, we know E of x is 2,28, right?
Yeah.
So this is going to be minus, E of x squared. So E of x we worked out previously. So it's minus 2,28 all squared. That's E of x squared. Yeah.
7, 5, 6.
Yep.
What if we were on to use the fraction?
Did you use that?
Fraction. Okay. You x.
No, I would be wrong. Okay, right.
So
So that is your variance of x, guys.
could you still do this with the frequency?
Yeah, I understand. I don't understand.
Maybe, but
I think she doesn't.
I wouldn't. So your variance of x is going to be, they said 0,746,
Yeah.
but I haven't answered the question. What is the question?
The question was find the number of what? Find the mean standard deviation.
Standard deviation.
Yeah.
So how do I find the standard deviations? So the standard deviation is going to be the square root. Which should give you apparently 0,86.
Yeah. Come on, it's what?
This is the first.
Huh?
Okay, I'm not too worried.
Problem? 86. Well, I use the fraction.
Fine, you just like the.
Yeah.
Like this.
Okay, do you understand the formula, guys?
Mhm.
Okay. Right, keep going.
Oh, so. How much will we like?
Hang on.
18 minutes. Oh, no.
Come.
Okay.
Has everyone got that? Okay. Come. I know you're tired, but it just gets it out.
So this is funny thing. From 3 days. And what is being Oh, don't. That's a question.
You can let some.
Someone is time.
I'm just going to do, sorry, B, doing? Yeah.
Standard deviation.
What do you mean?
Times the time.
Oh.
Right, so then it says, Seth noticed that the sample did not include female seagulls that laid no eggs. Okay. But so what did happen to the mean? That's pretty obvious. What happened to the mean if there were seagulls with no eggs? The mean would decrease, right?
Yeah.
Okay, so if you included that, the mean would decrease. Okay. And then, I would guess, I'm going to look at the memo now, I would say the mean would decrease. I would say the standard deviation would increase.
I would say.
Because what is standard deviation? It's average distance from the mean, right? Okay, the mean was sitting at whatever, 2 comma something. But now it's going to become more spread out because you've got like more things which are further away from them. North is further away from the mean and other things, right? So the mean would decrease and the standard deviation would increase. That is right.
I just have a question.
Okay. It's hard for me to just get my head straight.
I know, but this isn't like related,
Yeah.
it's the general
Yeah, yeah.
idea. With that,
Interval of learn of anything is
yeah,
quite over there.
my question, Sarah, is if you had to actually find doing something, would it be the definition of that? So if it's half, would it be different? If it's not, would it be? Might be.
Have you seen this? This is my paper.
Okay.
Okay, like.
If they ask me, I'd be shocked, quite honestly. with
Which-
all of these
Yeah,
letters. Yeah.
but they also include Lynn and E in these papers.
Then end that one. Okay.
Then you must be in
And they long rules, right?
Marching in time.
Okay. So you can take that one, you can start, yes, I'm saying.
But my question is, if it's times by half, like,
Yeah,
where-
then it's 5 to the half. No, what you're doing is you're using this thing. It's, okay. B is mean because you have to know all the log rules. Okay, I'll just tell you the log rules now. Okay. Right, but I would be shocked if they asked you B. I mean, they know that a lot of you are writing at the end of grade 11 now, and that's part of your grade 12 AP course syllabus. So, right, let me just show you something. Okay, on your formula sheet, if you look here, go to algebra and calculus formula sheet. Okay, and it gives you these laws here. Ln A plus ln B, then A,
Then A plus Lynn.
then A plus then B. See that? Is equal to ln A, right? Then they tell you, okay, ln A minus ln B is equal to ln A over B, right? And then they tell you ln A of n is equal to n ln A. Okay, don't worry about the last one, you won't need that. Okay, so, but to solve a linear equation, just add this to the notes, to the formula sheet. To solve a linear equation, algebra and calculus.
Just about calculus.
To solve, okay, a linear equation, you use this logic. Okay, that if you have ln of f of x equal to ln of g of x, single term on both sides, then f of x is equal to g of x. Okay, so add that onto your formula sheet. Ln of f of x is equal to ln of g of x. Okay,
And then there's about E.
then f of,
Okay, good.
then f of x is equal to g of x.
What do you mean good?
No, because like if you start doing that now, life's hectic.
Yeah.
Like, oh,
Fine,
don't worry about it.
okay.
We could actually give you.
You probably wouldn't do this in the paper. You did it last year. You did the May, this is the May.
Was the main, the paper, did you write the main paper this?
I think I can understand one, but the full finance modeling had E in it. We just like E.
Okay.
But if you wanted to do it in the paper, like probably not.
We're not doing finance.
Yeah.
Right,
No, right.
okay, let's do 2.2, okay.
Those have to write some. Personal statement.
Does that make sense now?
Yes.
Okay. You know.
Oh, I thought. There's no any difference now.
When Nicola is done by a B.
Yeah.
Can't take any minutes from the color to develop a reaction and start with it.
What is it?
Okay, so what has to happen, guys? The integral between what? 0 and 4 of what?
A over
With respect to
X.
must be equal to,
It
if they tell you it's the probability
was
density.
one, okay, yeah.
So the area under the curve is 1. You don't even need regular here. Okay. What am I allowed to remove?
The K.
Okay, right.
You still need 1 over x plus 1, I think so.
Okay, so now you're gonna have to go work out that using your calculator.
We plug that in.
Like that. Give you a funny number,
Oh, yeah.
okay? What's K?
1,6, you're rounded.
You know, give me the whole thing.
1,609 437 912.
Okay. Right?
You track the whole thing, so.
Right, yep. Now on your calculator, because I said show that K is equal to
1 over
1 over ln 5, go, you can say but ln 5, go work out ln 5 in your calculator. Go ln, and the button that says there,
Same thing.
5.
What do we do with that information?
You get the same thing,
Five
right?
is gonna be equal to.
How do you know? How do you know it's this?
Okay, what do you get for ln 5? What? This I got just using your calculator, right? So, hey, so K, listen, no, K is not that. K times that.
Is equal to 1.
Okay, sorry, so this thing over here. K, so you end up with K times that whole number. K times 1, what was it?
1,60.
60 dot dot dot.
Yeah.
Okay, is equal to 1, right? But they said show, so, but this thing must be, okay, but 1,6 blah 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 is equal to ln 5.
Yeah. Therefore, K over
Therefore, K times ln 5
is equal to 1.
is equal to 1.
And therefore, K is equal
Therefore, K is equal to 1 over
to
ln 5.
Wait, so how do you get your roller equals ln 5? Therefore, k ln 5.
I'm only doing that because in the question they said K is equal to 1 over ln 5.
Yes, otherwise
Right.
we can do this.
Yeah.
Then how would you prove the
Okay, so what they really, okay, without a calculator, okay, are we happy with the calculator?
Yeah.
If you say that you don't line that up.
Okay, otherwise I've just said K as the number, but the question says, what does the question say? It says show K is 1 over ln 5, that's what I'm doing there.
If that question wasn't there, we wouldn't have to use them, but it's what's it.
Okay, I thought you were saying that if it didn't tell you that, you would still work it out.
No, we could have been 1,6 blah blah blah, right? Okay, so, but just to show you, without a calculator, this is what they did, okay? They said, K, well, the integral of 1 over x plus 1, guys, what's, listen, stay with me. What's the integral of 1 over x? Look at your formula sheet. Integral going from right to left. The next, so 1 over x plus 1 is ln x plus 1. So it would become, this red bit over here would be ln x plus 1 between what and what?
0 and 4.
Between, the, I'm looking at this red bit here, right?
Yeah.
Okay, between 0 and 4 must be equal to
1.
1, right? Okay. So in other words, K, what does this mean? I sub in 4, so it becomes
Then 4 plus.
ln 5, right?
Yeah.
Minus
Then
ln, well, ln 1.
is equal to 1.
Is this the question?
Okay, this is just the other way, but I didn't use a calculator. It's actually a better way of doing it.
1 is 0.
Okay, but ln 1 is 0, so you get K ln 5 is equal to this 0.
Yeah.
Is 1. K is equal to 1 over.
Then 5.
Okay, that's what I'm using.
And they wouldn't do this.
I doubted in this now with the grade 11s writing.
You know, and all of the grade 11 students right now as well.
Yeah. Okay. Right. Last question, then a break. Okay. Find the median time for Nicola to develop a reaction. Come, what's that median? Yeah, but I talked about lens here. Okay, I'm gonna help you with that now. Okay. You're gonna have to use those log laws that are on your formula. Okay, everyone go try it, please.
How do I live?
Yeah.
Do it now. Okay, but just press on. And use those log laws. All righty.
So it's
That means I take pay out. I don't take pay out.
K is 1 over ln 5. You know that now.
Yes, but can I take it out?
Right.
Let me just leave it.
Yeah, I thought, I mean, when you dying.
I can find this, but I'm on.
Let's find them.
No.
Maybe I'll find what you want. Thank for that. Me too.
What's your basic idea, guys? For a median what?
Median
The area must be equal to 8. The area must be 0.5, right?
0.5.
So the integral between, what's your starting point? 0. That was 1, you would have started with 1, right? So between 0 and the median, of the function must be equal to
0.5.
That's the logic behind the median question. That's your starting point.
Yeah.
But now your median, so in this case, it's going to be the integral between 0 and m. Okay. Now ln 5 is just a number. So I can remove it. So I'm going to take out 1 over ln 5. You with me?
Yeah.
Doesn't have an x in it. Well, I'm sorry, I didn't listen. Okay.
Can't we just work out ln 5?
I would rather repeat. It's easier to write in that form, otherwise you've got to keep all the decimal places.
Yeah.
So I get 1 over ln 5 between 0 and m. F of x is then
1 over x plus
respect to x is equal to
0.5. Can you put that in your calculator to solve? Oh no, because you've got.
Okay. Right. If you want, you can write the whole number down. So if you want to go 0.5 divided by 1 over ln 5, you can, but write the whole number down. Okay. So what's 0.5 divided by ln 5? No, divided by 1 over ln 5.
0.8.
Okay, keep it at ln 5. So it'll be 0.5 ln 5. So if you divide by 1 over ln 5, it's times by ln 5, right? Because if I go 0.5 divided by 1 over ln 5, I get 0. I don't divide by a fraction. Okay. So the right hand side is, or you can just leave the ln 5 over. Okay. So I get 0.5 ln 5 is equal to. Right. Now you have to go integrate 1 over x plus 1. What's the integral of 1 over x plus 1?
Ln x.
Ln x plus 1, right? I'm going to say ln x plus 1.
And this is never been divided, so this is a different thing.
What are you talking about?
I thought we moved it over. This is a different thing.
I divided 1 over ln 5.
Yeah.
And I got that. But now I've got to integrate this 1 over x plus 1. So what's the integral of 1 over x plus 1?
Still integrated ln 5. We've moved ln 5 over to the other
I'm
side.
not, I've dealt with the ln 5. The ln 5 is gone. But I've got to find the integral of this. The integral of 1 over x plus 1. The 1 over x plus 1 is still there.
There's no ln there. Though.
I know there's not, but what's the integral of 1 over x plus 1 is ln of x plus 1. So I'm saying that the integral of 1 over x is ln x, right? So the integral of 1 over x plus 1 is ln of x plus 1.
Can we not just do it without?
No. Okay, the integral of 1 over x plus 1 is ln of x plus 1.
But I only know that 1 over x is ln.
So what
Look at your
the
table
integral
here.
of ln of anything is 1 over that thing.
Check this table. It's a function of ln plus 1 over x. It's function of ln x.
So what is the integral of 1 over x plus 7?
Ln x
Ln
plus
x plus 7. 1 over x minus 50. Ln x minus 50.
That gives you ln. You went 1 over x.
And then that's what we did. Right, okay, so I've got ln x plus 1 is equal to 0.5 ln 5 between what? between naught and
an M.
m. Right, go to your next step.
You multiply that in.
I'm not multiplying anything. What does the rule say?
Or N.
So you sub in m, right? So it becomes what? Ln of
M plus one.
m plus 1 minus ln of what?
Ln of one.
0, ln of 0 plus 1, right? And you understand what I've done there, Maddie? I've replaced m with x and I've replaced 0 with x. Because I'm using this law. The integral of f of x with respect to x between a and b is equal to a. I did this, I found f of x, that was the integral, and then I said f of b minus f of a.
You say equal to 0.
So that's equal to 0,5 ln 5. Or you could just write that whole number down. Okay, now,
So
okay, now, how do I solve a linear equation? I mean, this is right.
you get rid of that and you can.
You have to end up with ln of f of x equal to ln of g of x.
Yes. So you have to get rid of the.
Okay,
line.
so first of all, I have to make this one term. How can I make that one term?
Then one is
Well,
zero.
first of all, ln of 1 is 0. So
Yeah.
you work out ln of 1 on your calculator, that's 0. So you get ln m plus 1 is equal to 0,5 ln 5, right?
But so why did you take that away?
Check in your calculator, what's ln of 5?
0.
Oh,
Okay.
so why don't you explain what it solve?
You could use the calculator to solve function now, quite honestly. Okay, so you now use the solve function. Okay, so to use the solve function, you do this. Okay, you'd go, how do I do this again? Ln of x plus 1, ln of x plus 1, okay, is equal to, or you can even go minus ln 1, if you didn't recognize that, minus ln 1 if you didn't recognize that that was. So you can enter ln of x plus 1. Now you've got to be careful. If you're using the solve function, you go ln of x plus 1 minus ln of 1. Okay. You don't press the equals button. Okay. You press the alpha equals button, which is above the calc. See the calc button? Is it this way?
No.
Yes. See the calc? You see the calc button on the top left? Above that, there's a red equal sign. If I'm using solve, you're going to use a red equal sign. So you go alpha equal. Okay? Right? So I go ln x plus 1 minus ln 1 is equal to 0,5 ln 5, right? Then you do not press equals. Okay, you never press equals. You first press solve. So solve is shift and above the calc button. So you go shift, solve, and then you press equal. And hopefully it spits out the right ones. But it takes a while. Sometimes you have to look around the room now, have a can of Coke. Okay. And while it's doing that, I'm going to show you how you would do it. I wish we had. So this will become. Okay, then you've got a law that says this. If you're doing this without using solve, it's given us an answer here.
Yeah.
Is that the right answer?
Yes.
Okay. So it gives you 1,23661. Okay, just wait. Just to show you, for those interested without a calculator, okay, that'll become, so the solve button is when there's one answer. Okay. Solve doesn't work for quadratic. That's the problem, Kiara. That's why I'm nervous. When you've got more than one answer, solve only gives you one answer.
Yeah.
And a quadratic, you get two answers.
So, but
So
if
with
they
any,
give me the right one.
I know you're lucky. Sometimes it's not going to be the right one.
Sometimes
It's
it'll
going
be
to be the
right.
wrong one. It gives you the one closest to 0.
Honest, that means probably closer than what I.
There's a law that says A ln B is equal to ln B A. So 0,5 ln 5 is equal to ln 5 to the half. Okay, so you get m plus 1 is equal to 5 to the half,
And then you solve for it.
and then you solve for m like that. Okay. But that's not really. I dashed that with all of these lists to show that these very means I did, yeah. But I suppose it's coming more last night. What? The press equals now. Then you got to press equals. Press equals and you have a blank screen for a while. Now the calculator, the man inside there is working hard. Okay? We didn't work a bit. Wait. Hey, wait.
The solve function is the nicest
Can you
function.
give me an answer yet?
What?
There we go, let's go.
So,
Yeah. Right, have a break, 11:54, we'll start at 12 and then do another half an hour. Then we're done.
Wait,
What?
So, I know, FB minus FA,
Yeah,
correct, right?
yeah, so if we can let the end
I
plus,
just learned.
so the integral of 1 over x plus 1.
I'm not there, I'm saying, length, and then
Leo.
bracket over here. Would that not give you minus length?
So you get ln n plus 1.
Yes.
So on your calculator, see what ln 1, what it says in book, enter ln 1.
Oh. Oh, 0. But if I just put, but I can leave it there if I want to, right? Just so I don't confuse myself.
Yes, you get ln n plus 1 minus ln of 1. So make that
Yeah.
ln 1. Now you can go and solve function in the calculator.
Oh, okay.
Okay. Okay, 5 minutes to start.
So 1,236.
Yeah.
Yeah. Oh.
So that's M, right?
Yeah,
Yes.
that's your medians.
Please can they not put one of these in it?
I don't know. I mean, I'd be shocked if they did.
But so 2019 was back when you said that grade 11's doing it right.
Yep. It was also pre-COVID, so things were harder.
No, this is ridiculous. Oh, no.
Who wants to mass rock? I think we do it now, guys. Yeah.
This is the hardest stuff. This and integration.
This is not hard stuff, but this is the stuff we relate about.
But you're right about it. You never know when you're actually not going to get another.
So you know what? I'm thinking I just withdraw myself from this exam that we're writing.
I won't get you.
You also can't.
Even if you can 10%, I don't care.
So, but I can 10%.
No one's going to see it.
No one's gonna see that paper ever again.
Oh, yes.
You burn that paper when you receive it.
Like how does what if the American University makes
They don't even know you've been writing it.
Okay.
You don't have to submit it.
Okay, so I can.
It's literally a separate certificate. Nobody ever has to make
So,
sure of this
Can
again.
you find the name of the examples first? Something like that.
There's no stress. Why the stress? It doesn't have to come. There isn't stress.
Okay, so I don't have to study.
No. But then you'll do very badly.
That's exactly. And then you do the alpha usage. And then you put the rest of it in 0. And then you just do shifts. I'm sure I should do
I honestly wish it was a course time.
so that I could study for like 10 hours. Yeah. Okay, great.
That's not a bar.
I need more hours in a day so I can sleep answer. Right now I have to choose.
That's not in grade 11 we shouldn't be. What do you mean? You should just relax.
How? It's third to grade 11. I applied to uni with these marks.
So then.
Just so no, how am I gonna get straight any degree if I have 65% of physics? I'll end up doing, I don't know, a teacher day.
Oh, you will. What? I didn't read that. Read it. What? What? No. So, what? It's a good person. What did you get? I'm gonna read it because you're in front of me. No. I just saw like the first line.
Yeah, you're still online.
Yeah, everything goes time.
There's got a few.
But I tried.
Okay. Right. Well done, people who stayed online.
I get it.
Right, guys, last half hour. You're right. Like all. Yeah. All right, I know you've got half an hour to go. Let's get it. Okay. Right. Next page. Right. Let's go. Question 3.1. Want to memory? Okay. Right. Half an hour. And we go. Now you're tired. Right.
Yes.
Okay, but I'm gonna don't do if you're practicing on your own. Okay. I'm gonna be doing 2019, 2020 and so on. But there's 2021, 2022. Okay. 2022 learns for the videos. Okay. All right. So go try at 3.1.
But we know that that's what the property says, as they always say.
It's required to move on to the next page. Oh, yes, no,
Yeah, that's great. It's not it's
oh my God, yeah.
Yeah. So if we know the government, and property, that's what it is, the property that's great. Yeah. So therefore, this number. Which is the probability that's great.
3.2, you need this formula, by the way. For 3.2, on your formula sheet, it says to you probability of A given B is condition probability. So you're going to need that formula for 3.2.
I.e. what means zero variance will not produce zero.
Right?
Where that explains the notation, it says I.e. with.
It's always, it can be assumed. Okay, they will tell you that always. But that, basically, this just means you're working with your. Okay, that just means you're working with your table on your info sheet.
And will they tell me that that's what that
You work-
means? Should I know what the Z score
For a Z score, if you look at the back of the table, it tells you there that for a Z score, sure it tells you that. The mean is 0 and the variance is 1.
No, they don't.
No, they don't. Okay.
So it's
Yeah, you can't do that. The table works on that assumption. Okay. Yeah.
It's not asked for this paper.
They didn't ask it, then ask it here. Okay, but 3.2 is quite tricky, guys. So if you get stuck on 3.2, don't wait for me. Okay, if you get lost on 3.2, go to 4.1.
like this with the school.
Yes, the Z is the Z score. Okay. Okay.
What is that? I think it's one totally my today.
So A is just asking you that, right? What's the probability that Z is greater than 1,1?
Yep.
So we've just got a normal distribution, but there's no X score because only Z. Where's your mean? At 0, right? Z score, your mean is 0, yeah? Z, what is the Z score? The number of standard deviations away from the mean. That they're saying, what's the probability that something is more than 1,1 standard deviations away from the mean? So we've got a Z score of 1,1, and we're looking for that area over there. We've got to get table, look up at Z score of 1,1, what do you get? 1,10, 0.3643, right? What's 1,1?
What? Oh, yeah.
It's
0.3.
0.36. Oh, wait, no,
No. That's what, 0.343643.
Yeah, but 0.5.
So it's going to be 0.5. So this is 0.3643. That's 0.5 minus 0.3648. Should give you,
1.57.
yeah.
I thought you could. I didn't. So always when you add.
Call down the line.
You know, very.
You don't have that either. Free.
It's binomial, isn't it?
And there are two ways we do the next one.
Okay.
Or am I crazy?
Oh, it's all of them. Oh. And then it's just going to figure out.
We're happy with this one. Can I have the start?
So how did you do 0.3643? Did you go
I
eight?
looked up the Z score of 1.1.
Except the revised plan.
So,
That's 20.
so Z score of 1.1. If you look up a Z score of 1.1, it's going to give you this area over here. Remember the table, that's,
Yeah.
that area there is 0.3643. So to get Z bigger than 1.1, it's going to be
Yeah.
0.5, chop out that. Okay.
Yeah.
Okay.
Well, probably. Yeah. That's all right.
Everyone okay with it? Have you got this?
Yes, sir. That's what you're working on.
I didn't say, oh, because this has the opening in the minus.
Yes, but I almost haven't. Oh,
So I have to get you and then I have to add.
to new current. Yes.
It's the.
So the one way you could do this question is using this formula.
What's that?
Is that 0.2?
Okay, so that's the one way you can do this question.
Yeah.
Okay.
So.
Do we know the probability of R?
Yeah.
Okay, so we know that that already is equal to, what was the answer for that? 0,
And no comment,
The last-
1357.
1357. Right. So go work out the probability of Q.
Okay, for a second, I thought it was. I'm using this one.
But we don't know where I think it's the.
I'll do that now.
The 98%.
So you think that's probability of Q, right?
So it would probably, the probability of Q be 2 times
Yeah.
H of 1,8.
So if you look up H of 1.8,
Is this for confidence? What's it?
1.8 is 0.4641, eh? That's it.
So what is the answer for?
Hang on.
8.13? So much like confidence.
What does that give you?
0.928.
9282, right?
Yeah.
Okay, so now I've got probability of Q,
All right.
right? Now, let's, okay, everyone okay after that? Let's do the question. Okay. Right, now the probability of R and Q, let's think about this. Everyone okay here?
Oh, the double line.
So, R was what? That Z is greater than 1.1, right? And Q is that Z is, guys, Z is bigger than negative 1.8 and less than 1.8. And means both conditions have to be met, right? So if both conditions R and Q are met, what has to happen? Well, Z has to be bigger than 1.1, first of all. You with me? So that's it, because both things have to happen. Okay, and these both have to happen. So the Z is greater than negative 1,8 isn't really relevant, right? So if both things happen, where does Z lie between?
Negative 1,8.
It has to be bigger than 1,1 first of all.
Yeah.
And then what does it have to be less than?
1,1, 1,8.
Okay, so do you agree with me? This is the AND situation. 1,1, 1,8. That meets both the conditions. Z is bigger than 1,1, right? Yes, and it's also bigger than negative 1,8, so it meets that condition, right? Okay, and it's less than 1,8. So this is the probability of Z of R and Q. Does that make sense? Both and means both stay with us.
Yeah.
And means both conditions have to be met.
Yeah.
So that area there is the probability of R and
So you
Q.
just go h of 1,8 minus h of 1,1.
I'll read this.
Right, so go with that out.
So if we had the formula for that for the this, the integral.
Okay, the table does it for you. The table does normal integrals. The table's basically done the integration for you because the formula
No. Yeah.
the curve is the Bishop form of the line. Okay, don't want to be in there.
Probability of the right answer.
Yeah, like, you need to look at it.
Times the
Yeah,
ag.
the easier way, actually.
Yeah.
Okay, so then this would be equal to what? H of 1,8 is
0,4641.
0,
4641.
Minus
and H of 1,1.
0,3643.
So the probability of R and Q is 0,4641. Which is what?
0,0998.
998.
Yeah.
Okay, so this will be 0,1357 plus 0,1928 minus 0,0998. And go with that out. There's another way to do this one.
Yes.
Okay, which is probably easier.
0,964.
What do you get?
0,964.
Okay, so that's the one way of doing it. Please remember. Okay, right, so you get 0,
Oh no.
will be right. Okay.
Oh, you can just say 0,1.
So the easy way to do this, is everyone happy with that way? Okay, everyone got that down? Okay, now what does all mean, right? Okay, I'm going to show you an easier way of doing this.
Yeah.
Okay, the all scenario means, okay, either it's all the areas that occur, right? All means any area, right? So if you're looking for the probability of R or Q, the probability of R is that, so R represents that Z is greater than 1,1. And Q represents that Z lies between negative 1,8 and
1,8.
now if it's an all scenario means okay that if either of the events can occur, then that's what we're looking for, right? Okay. So Z is naught over here. So the first one is Z is greater than 1,1. Where's that area? Okay, 1,1 is over here. So that Z is greater than 1,1, right? Okay. The other one, this is a much easier way of doing it. Z lies between negative 1,8 and 1,8. Okay. Where is that? Okay. Negative 1,8 and 1,8 is over there. Okay, so that's starts from there. So that's that area over there, right? So where did the red or the blue occur? So blue was over here, right? Okay. Where did the red or the blue occur? It's just then greater than negative 1,8.
Yeah.
Okay. So all means the blue or the red. All of them. Everything that's shaded in, you include with the all. And is what? Both. You with me? So all, the easiest way to do this question is not that complicated formula they use.
Yeah.
It's to work out that the probability of Z is greater than negative 1,8. Okay? Which is going to be equal to what? 0,5
plus.
plus what was
0,461.
A lot quicker.
Yeah.
Okay, but for some reason, the memos that always have that and one. 0,961. So, or if you shade in areas, anything that's shaded in will be the or scenario. And means what?
Only the thing
Only the bits with colouring in overlaps, where both are coloured in. Okay, we've got 15 minutes to survive. Come on, dig deep, dig deep. Okay, but the next question is a bit sneaky. There's a sneaky idea here.
So this is like that sneaky one you gave us in our test last time.
Well,
I think it's exactly that.
Yeah, it is exactly that question actually. It was like, yeah,
I used this one. We should have been looking at the IEB notes. Yeah, I know, we should have found it ourselves. I said I just found it. It's good at that.
I think, I don't know if this is new, it was a.
And you missed learning the myth.
That maybe just was new, it's the same thing, and it's just tomorrow. I don't know, but I don't know how to do anything. Yeah. And some practice. No, they're using this.
I never doesn't know what nobody else. I mean, also.
No, other tables.
okay, so you've got this formula, right? Which says that the probability of A given B is probability of A and B over probability of B. That's your conditional probability formula, right? Okay, there was it. Okay, so how can I rewrite this? I rewrite that using that logic over here.
well, that's your probability, so that's H of
So how can
Z.
I rewrite that?
Try to work out the.
Use this formula. You could write what? Probability of A and B will be the probability that X is greater than C,
And
and
the probability
and X is
greater than 280. Over X is greater than. Oh.
okay. Yeah, we've done just applying that formula. But here's the trick really. Okay. They say in this question, okay, so you've got, it's a bit quite tricky to kind of understand what's going on here. Okay, so it says here, you've got a random variable X, which is a normal distribution about a mean of 200. Okay, and a standard deviation plus. It is given that probability of X given C, just listen to me please, by the way. Okay, they tell us the probability of X given C. Okay, what does this mean? Okay, it means that you're only working with the sample space of X is bigger than 280. Okay, they're saying to you, on condition, remember what comes, the given comes after the line, right? So this means, hey, you've given X is bigger than 280. Given X is bigger than 280. So we're only working with the X scores bigger than 280.
Yeah.
Given X is bigger than 280, the probability that X is bigger than C is 0.625. So tell me, does on this diagram here, so you've got 280 over here, is C to the right or to the left of 280 on the horizontal axis? Pick your neighbor.
X is green, given that X is greater than X. Oh, it's on the left, so.
If this was the case, if you had this, if that was naught, it's okay. If this was naught, what's it telling you? It's saying that if X is bigger than 280,
Probably the X of.
probability that X is bigger than C is it's impossible. Okay. So then it'd be, so yeah, it would be to the left. P would be to the left. But now, okay, given that X is bigger than C, is it impossible that X is bigger than 280? Given that X is bigger than 280, is it impossible? I'm confusing myself now. So given X is bigger than 280, okay, The probability that X is then also bigger than C is 0.625. So was C going to the right or to the left of that? Must be to the right. Okay.
It is a possibility.
Okay, so C must be over here. Okay. Which means, okay, does that make any sense to you?
No.
How can I explain this? I think of a way, it's a, how can we explain this? Okay.
Oh, wait,
So if X is, so you're given X is bigger than, given X is bigger than 280. Okay. Is it impossible that if X is bigger than 280, X is bigger than C? Shouldn't use naught. Okay.
So can I try?
Try. So if X is bigger than 280, the probability that X is bigger than C is not equal to the whole area. Okay.
Can I steal your pen?
Yeah, go.
So if you've got this curve here, okay, and then this is 280 lies here, okay? If they've given us that this is the event that has already occurred, X has to be greater than 280. So given that, X lies in that space.
Yeah.
Understand that?
X has to be there.
What is the possibility that X is greater than C? Let's say we've got a value here and a value there, okay? If the probability that X is greater than, if the value of C is 0, C can't be less than 280. If it's 0, that means that C is less than 280 because it cannot lie in that space. Therefore, X cannot be greater than 280. Does that make sense?
X has to lie in. So they're telling you we're only working with the space. This is the space we're working with.
Okay.
This is the new sample space.
Yes, we're only working in the shaded region.
So what about the
Okay.
625? I'm confused.
So then, to find out whether it lies on the left or the right, they've given us that X has to be greater than that if there is a possibility.
So there is a possibility.
Yes, so if there is a possibility, it means that it has to lie in the region where X is. Does that make sense? They told us that X is greater than 280, but if X can now not be less than 280. Does that make sense? That has to be on the right.
It's actually so simple. It's actually
Yes.
It's just the fact that it's above 0 is showing that there is actually a possibility of it.
Yes.
And it's saying given
This-
X is
this
greater
is
than
that,
280,
but
so
since
we know it has to be.
Exactly.
What this is saying is that given X is bigger than 280, okay, then the chances that X is bigger than C is 0.625.
Yeah.
Okay. You with me?
There is a chance that it is greater than Z. Yeah.
So it's not the whole sample space.
Yes.
Okay. If it was X is bigger than 280, if C was to the left, what would happen? Then the probability that X was bigger than C would be equal to 1.
Yeah.
It would definitely happen.
Yes.
If C was here, and you're told, okay, I'm only working with the probability that X is bigger than, okay, I think I've got it now. Okay, if you were told, so do you all understand the question is saying, I'm only interested in that area.
Yeah.
Okay, I'm working with the X values which are bigger than 280.
Mm.
Okay, if C was here, okay, then the probability that X would be bigger than C, okay, then this probability would be equal to, okay, that would be equal to 1.
Mhm.
Because the probability that X, if C is to the left, what's the probability that X is bigger than C? It must be equal to 1.
Yeah, it's in the sample space.
Because
Yeah.
yeah, so there's C. Okay, the probability that X, given that X is bigger than 280, what's the probability that's bigger than C? Has to be
Mhm. Yeah.
certain, right? Okay, so C must lie over there, right?
Yeah.
What's important about that is this.
Never
and
mind,
if-
just to the left.
Okay, so if C is over here, okay, I
See it in the shaded region.
C is in the shaded region. Does that make sense? Okay. So if you get a question like this, C is in the shaded region, right? Which means what? Which means that this area over here, okay, as this area over here is the same thing, okay, as the probability that X is bigger than C.
Mhm.
Why? Because what does that mean? Both conditions have to be met.
Both conditions are.
X has to be bigger than C and X has to be bigger than 280. So in other words, X must be
Like in that.
bigger than C. X must be, X is C and 280. This is that region over here,
Yes.
which is the same thing as X is bigger than C.
Yeah.
That's really the key of what I was trying to explain. Okay. So if you had this situation, that the probability of X given C and X is greater than 280 is equal to 1. That would mean C would be where?
Um,
To the left of 280,
yeah.
right? Because the probability, given that it's bigger than, so it's working in that space, okay, that it's bigger than C, it has to be the truth, right? But if it's anything except for 1, then C must be to the right, okay? And if it's to the right, the probability that X is bigger than C and X is bigger than 280 is exactly the same thing, and means both regions are
Yeah,
same.
yeah.
So it's the same thing as just probability X is bigger than C. So now the question becomes, the probability of X is bigger than C and X is bigger than 2, given X is bigger than 280, is the probability of X given bigger than C over probability X is greater than 280, and that is equal to 0.625. So what's really, so the probability of X is bigger than C is going to be equal to 0.265 times the probability that X is bigger than 280. With me? Right, so what's, go work out that. That's just a normal distribution theory. What's the probability that X is bigger than 280? You're gonna have to go do this question again. It's a very common question these days for some reason. Yeah. Okay. So in this data, what do we know? Mu is 200. Sigma is 50. We're looking for the probability that X is bigger than 280. I'm looking for that area over there. Right, go work on that area. Come. Last little bit. Okay. Okay, go through it again. Okay. So Z is equal to X minus mu over sigma.
X is greater than 2. So it has to use that last. So what's the same of this? I don't know what we're doing great thing.
What's Z equal to?
In 1 comma.
1 comma?
You find the problem that probability is the same. Yeah. Yeah.
What's H of 1,6?
Kind of 445 here.
So probability X is bigger than 280.
348. No, it's coming 0,348.
Am I right? What is it?
You're right. 1,0558. Sorry, I'm sorry.
So that's appreciated. It's my only particular. Okay, there's one of the 2 elements and this one of the, yes.
Right, so that answer over there. Okay, so here your answer for this then.
From 28, open bracket, 0,0548.
What did I give you? No, is that 625 not 265?
Yeah.
625, so. That's 0,65, I don't know how I write that. That's 0,625. Times 0,0548, which is equal to
0,0345. No?
0,
Probability is 0.
we're not done guys, 1 second, 0,0
345.
343, right? Okay,
Yeah.
that's for your completeness. But what was the question?
What's
Okay, the question was,
find C? Find the
Okay.
value of C.
so what is the value C, right?
Now we go back to our table because we've got the.
Okay, so now we go back to our table. Okay, so the probability that X is bigger than C, okay, is equal to
0,34. 0,09. Yeah.
Okay.
0,09.
If I want to 291.
Sorry?
Okay, because now,
Yes, it does. X.
Okay, what was the question? The question was, let's go through this again. It seems like so long ago since we started. Okay, it says the random variable X has a normal distribution with a mean of 200 and a standard deviation. Find the value of C if it is given that thing. So we worked out the probability, we've got the probability of X is bigger than C was equal to what? Something that answer I just worked out?
0.034. 3.
Is equal to 0.0333. So what have I got now? I've got C up here.
What's your H value?
There's C. This area is 0.04343, right?
Yeah.
So this area is what?
0,
So H of C is equal to 0.5 minus 0.0.
65. Okay.
What's it?
0.46575. Oh, yeah.
What?
0.465. Sorry, 0.4657.
Okay, so that area is 0.4.
Did you look at that value on your table?
Now look at that value on my table.
1.82.
And you should get a Z score is equal to, so the Z score of C is 1.82.
Yeah.
Okay.
Formula.
Then you use your formula and you say Z is equal to X minus mu over sigma. Okay, so we got 1.82 is equal to X minus what's mu? 200 over 50. If you solve for X, you get X, which is P, which is equal to P minus X. That is a vicious question, right? Never thought one thing, right?
So this is like 8 marks. And we have to write like 100 marks in 60 minutes. When my 4 minutes is up, I'm putting up, right?
Yeah. God, I'm exhausted.
When are they writing?
They practice it on Wednesday. They'll probably get trapped with it.
Yeah, but then when you get to it, they start to move. How would you understand the question?
Thanks, Dan. I like that, this show. I like that. Why is it that cleaning fun? It's probably the same time.
I'll make sure. Even if it was bad, just not comparing myself to something. We are all well, I don't know about everyone, but me and Matt still regardless of how it goes. Yeah, no, either way, when there's tears of joy or tears of sadness, I'll be one of them. It's tears of joy, it's just tears of joy that's over.